Okay, welcome back, everyone. I hope you all had a good spring break and you had some experience with finding some information about sample means that we talked about last week or the week before. This week, we're going to talk a bit about proportions and how the central limit theorem works with proportions. And then we're going to talk about computing probabilities with proportions. It's very similar to what we did last week. We're just going to change the equations and talk about some slightly different types of questions. In the next section, we're going to expand on some of these ideas a little bit more. When we talked about with sample means, right, when we sample a population to determine a proportion, we'd expect that most of our samples are going to be closer to the true value of the proportion. And so if you ask people a question and it's 70% to 30%, if you sample folks, a lot of the times that'll be about what you would expect. You'd expect about 70-30. So we can use the central limit theorem for proportions, but we have to change up how we deal with the standard error. The standard error, right, is the standard deviation of the sample proportions in this case, instead of the sample means. And so we have to make sure that we meet some assumptions. First of all, the number of participants, or the number that we have, times the probability has to be greater than or equal to 10. And also the number times the complement of the probability. This just means that if we have really small probabilities on either side, we need to have a lot of people in those groups. And we just want these numbers to be large enough to work with. The way that we calculate the z-score is slightly different. Okay, the p with the hat over it, this represents our sample proportion. Right? So this is going to be the sample that we measure. This mean that you see here, or the mu that you see there, this is the population proportion. So this is what you would expect in the population. And then the standard error is calculated this way. And if we write this, you sometimes will see this written as P times Q divided by N. So we can try this and find the probability of the proportion being between 0.20 and 0.23, or between 20% and 23%. First of all, we can start off by finding the expected value of the proportion, which in this case is just P, 0.24. Okay, N is 103. We then want to calculate the standard error, which is P, so 0.24, times 1 minus P, so 1 minus 0.24, divided by N, or 103. Throw a little bit of that in the calculator, and you should get 0.1824. Take the square root of, divide by 103. 177. And then we take the square root of that number, and you should get 0.0421. We need to find z values for our proportions. So the first z, we'll start with the lower one. And so 0.20 minus our mean, 0.24, or our expected values, the more appropriate way, divided by the standard error, which is 0.0421. That's negative 0.04, divided by 0.0421 minus 0.95. The second z value, 0.23, minus 0.24 divided by 0.0421, negative 0.24. And so our z value, here's z2, here's z1. And so we're looking for essentially the area in between these two. And to find that probability, we would then essentially turn to Excel to calculate that. So let's see if we can get that here. If we want to find the probability to the left of z, or the probability between these two values, we want to do the probability of Z2 minus the probability of Z1. So negative 0.95. Oh, I'm sorry, 0.24 minus, oops, we find the probability 0.2341, 23.41%. Let's take a look at another example. Here, a Pew Research report indicated that 37% of teenagers aged 12 to 17 own smartphones. A random sample of 150 teenagers is drawn. And we want to find first the expected value of the proportion. Well, in this case, the expected value is what we'd expect from the research report, 0.37. Now to find the standard deviation, or the standard error in this case, standard deviation of the expected proportions, 0.37. 1 minus 0.37, or 0.37, 0.63. Divided by, we have a sample of 150. That's the square root of. And then when we take the square root of that value, 0.0394. So now we have the expected value or the mean, the expected value of the proportion. We have the standard deviation of the proportions. Let's find the probability that more than 35% of the 150 that we sample own a smartphone. We first need a Z value for 35%. In this case, the population, or the sample proportion, 0.35. So to calculate Z, 0.35 minus 0.37 divided by our standard error from before, 0.0394, 0.5. We'll just call it 0.51. So that's about right here. And so we can draw this line. We want all of the area over here. Again, here we'll need a table or Excel. If we insert from Excel, it's gonna, we want to find equals. I'm trying to see if I can make this a little bigger. Zoom in a little, you guys. Equals, we want 1 minus the area to the left of negative 0.51. So 1 minus norms dist, and then we want Z of negative 0.51. Because remember, the norms dist part, that will give you the area to the left. Do this, so there is a 0.6950. Here's where I can change the color. Nope. So 1 minus this area here, which is given to you by Excel, gives you this. We can then ask, would it be unusual if less than 31% of the sample own smartphones? Well, here again, we're going to calculate a Z value. .0394. And from our Z value, negative 1.52. So about right here. And so if we want to find the area to the left of negative 1.52, that's a lot easier in Excel. There's no subtraction or anything. The equals norms dist will give it to us directly. minus 1.52. And so the area here is 0.0643. Okay, remember, we consider things to be unusual if it happens less than 5% of the time. This is 6.3 or 6.43%, so it's not less than 5% of the time, so it's not unusual. Let me click out of this. One more example of proportions, or maybe two. General Social Survey reported that 56% of Americans saw a doctor for an illness during the past year. We sampled 65 adults. What's the probability that more than 60% of them saw a doctor? Okay, so our expected value of the proportion is 0.56. Okay, the sample value that we're interested in, 0.60. And we've got a sample of 65. Calculate the standard deviation. That's the only other value that we need. 0.56 times 0.44 divided by 65. And then we take the square root. And you get 0.0616. To find z, we then take the value that we're interested in minus the expected proportion divided by 0.0616. .649, so we'll call it 0.65. 9. Just to make it simpler. 0.65 is about right here. We want the area, let's see, more than 60%, so the area above. And so again, that's going to be 1 minus the area below. When we insert the Excel here, just so you guys can see it, equals 1 minus norms dist, and then we can type in the z value, which is 0.65. 1 minus that, and that tells us this is 25.78%, or 0.2578. One more example here. We have for a certain type of computer chip, the proportion of chips that are defective is 0.10. Okay, so this is our expected value of the proportion. A manufacturer receives a shipment of 200 chips. What's the probability that the proportion of the defective chips is less than 0.08? And so that's the part that we want to look into. That's our expected value. I'm sorry, that's our sample proportion. We then need the standard deviation of the sample proportion, or of the proportions, the standard error, 0.10, 0.90 divided by 200, and then take the square root, 0.0212. And then to find our z value the same way, our sample proportion 0.08, the expected proportion is 0.10, divide by 0.0212, negative 0.943, or let's call it 0.94. That's about here. And we want to know what's the probability that the proportion is less than this. So what's the probability that it's less than this? Again, that's easy. In Excel, you would type norms dist and then your z value minus 0.94. So that's what we're going to do here. and we find 0.1736. So there's 17.36% probability that the proportion of defective chips is less than 0.08 or less than 8%. And so here you can see that you can use the Z distribution the same way that you use it for sample means. You can use it for sample proportions. You just have to calculate the values a little differently, more particularly the standard error or the standard deviation of the sample proportions. You have to involve the expected value of the proportion rather than the means. In the next section, we'll talk about a bit more of how to use some of these distributions. And if you have any questions, please let me know.